All right, so here we go. This is the final part of scales and constructions and scales for you, just in case you still need a little help completing these that were classwork. So I'm picking up here with the scale factor and scaling to find model size and actual size. So we are going to look here at numbers 9 and 10. Just a quick reminder, we're going to set up a proportion, and in our proportion, the first ratio will have the comparison of using our scale factor. The second ratio will be using the information that they gave us and the unknown information. So, to start with, we're going to start with our scale, which is 1 to 8, and our model, and we don't know the actual length, okay? This is where we, as we call it in class, crossing circly, cross multiply, divide. You can also look at it like we're writing an equation. We would do 1 times x is equal to 8 times 6. However you have learned to do it here in class works just fine. So we have 8 times 6 will give us 48 divided by 1. So the actual length is 48 inches. Second one, or number 10, I'm sorry. We're going to start with our scale factor again. We don't know the model height, and the actual height is 28. So again, we cross circle, divide, multiply, whatever we want to call it. And this one I can't do in my head, so we'll have 28 divided by 8 to get x is equal to 3.5. And that's going to be centimeters. Number 11. Part of these standards, the 7G 11, 12, and 25, says that we have to be able to understand quadrilaterals in different shapes. So this question here, your cheerleading coach tells you to organize the squad into the shape of a quadrilateral with exactly 1 pair of parallel sides. Which quadrilateral should you instruct the team to form? So quadrilateral meaning 4. It's a shape with 4 sides. We are looking for a shape with 4 sides with exactly 1 pair of parallel sides. Parallel meaning that the lines will never intersect. They stay the same distance apart forever and ever. If I'm thinking of my quadrilaterals, I can think of my parallelogram. Those are all parallel sides. I can think of my rectangle and my square. Those are all parallel sides. The one quadrilateral that we talked about in class that we know of would be a trapezoid. That would give you a quadrilateral with only 1 pair. These ones here are parallel. The sides are not parallel. So this would be what you would put your cheerleading squad into to answer the question. It would be a trapezoid. Number 12, a scale on the map is 1 inches to 50 miles. The actual distance between the cities is 350 miles. What is the distance on the map? So I always start with my scale. So I have 1 inch and 50 miles. The distance between the 2 cities is 350 miles. So I want to make sure my miles is in the denominator, or the bottom, just like my miles is in my scale. I don't know how many inches. So again, we cross circle, and this is going to leave me with x equaling 7 inches. This should be, once you get it set up like this, you guys are really good at proportions, so we should be okay with that part. We have a scale factor of 1 to 15. If we're looking at the tree, the model is, we don't know how tall, and the actual size is 30. So when we cross multiply, 30 times 1 is 30 divided by 15. X should equal 2. And then when we're looking at the door, my scale factor first, the model height is 10. I don't know the actual height. So again, times 10 is 150, divided by 1 is still 150. So a basketball player is 6 feet 8 inches tall. A model of the basketball player is 5 inches tall. What is the scale factor? So I want to turn my 6 feet 8 inches into all feet so that I can convert from feet to inches, or so my scale will be from feet to inches. So first of all, I need to figure out 8 inches is what portion of 12 inches, which is a foot. So it's going to be 0.67. So we have 6.67 feet. Okay? And you're always going to divide the actual divided by the model. So we have 6.67 divided by 5. That's not right. 6.67 divided by 5. So my model will be 1 inch is equal to 1.33 feet. All I did was divide this 6.67 divided by the model size, which was 5. Okay. Number 16. A scale drawing of a movie screen is 21 inches long and 9 inches tall. The actual screen is 30 feet tall. So we need to figure out what's the scale drawing. So I have the height of the actual screen and the height of the scale drawing. So remember, we take the actual size, and so I'm looking at feet tall, so I'm going to divide it by 9 inches tall. So every 1 inch is equal to 3.3 feet. I need to find the perimeter and the area of the movie screen in the scale drawing. Okay, so I know that the scale is 21 by 9. So my perimeter, if I have a rectangular, it would be 21, 21, 9, and 9.